Hey everyone, welcome back to Medicine Bar. In this video, we are diving into FRQ2 from the 2024 AP Calculus PC exam, all about particle motion in the plane. So from speed to distance and then about direction. So this question packs it all. Let's break it down step by step and master parametric motion together. So yes, it's question number 2 and it's with calculator. Let's get started. We are going to discuss a calculator based problem, which is problem number 2 here. And this is about particle motion in an XY plane. So let's get started. A particle moving along the curve in the XY plane has position x of t, y of t. So it's parametric function. At time t seconds, where x of t and y of t are measured in centimeters. It is known that x dash of t is 80 minus t square, y dash of t is this. At time t equal to 2 seconds, the particle is at the point 3, 6. Now we're going to break down all the problems which is listed here one by one. So this is the basic description. So parametric form and the derivatives of x part and y part is given. Also, they give a time t equal to 2 where the particle is. So let's get into first problem. A particle moving along a curve. So the same description. Find the speed of the particle at time t is equal to 2 seconds. Show the setup for your calculation. So speed means modulus of velocity. So for this function, you can write speed at time t naught, like any time t naught, is equal to square root of x dash of t naught square plus y dash of t naught square. This is a direct formula. And basically, modulus of v of t is the speed. So modulus of v of t is nothing but, like, what is v of t? V of t is x dash of t comma y dash of t. So this is how this formula, like we got this. Now, x dash of t is given, y dash of t. We are calculating speed at time 2. So speed at time 2 is equal to t equal to 2 seconds is x dash of 2 whole square plus y dash of 2 whole square. So we need to plug in. So what is x dash of 2? We need to solve. X dash of 2 is 8 times 2. So replace t with 2. 16 minus 4, which is 12. Then y dash of 2 is this thing. So we need a calculator here. So minus 2 plus square root of t power 1, 2 power 1.2 plus 20. That is what we need to solve and square this. So this will be 12 square, and this when you express, so it will be like this. 12 square plus this stuff, minus 2 plus square root of 2 power 1.2 plus 20 the whole square. So we can use the calculator part to solve this, and we will get approximately 12.3048, which is approximately 12.305. And we can easily use the Desmos here. So I will show you how I calculated and got this value. Okay, so all I need, I have a square root. And what are the values? 16 minus, first I have 12 square. That's easily, we can find it. So 144. Plus, then comes the complicated value. So use the bracket. We have multiple brackets here. So you can use either round bracket or square bracket. So minus 2 plus square root. So you can type SQRT for this. 2 power 1.2 and shift plus the number 6. Basically, it will be 1.2 plus 20. And this should be squared. So likewise, you can easily find it 12.3048. And making to 3 decimal places will be good. So 12.305 here. Right? So from this, I got the result. So you can easily use Desmos for numerical calculations too. Let's go to the whiteboard. This is the reference. Okay. So 12.305 is final answer. Very simple, A part. Let's get into the B part. Find the total distance traveled by the particle over the time interval. Show the setup for your calculations. Okay, let's go for it. So total distance traveled is, we know, like, it's an accumulation of rate of change. Total distance is accumulation of rate of change. Rate of change of distance is velocity. So here is the formula for total distance. Accumulation means integral. You need from 0 to 2. So it is parametric function. So the velocity is square root of x dash of t square plus y dash of t square. Or you can use the bracket and then dt. So we have x dash of t given in the problem. So they have given in the description at minus t square and y dash of t. I'm going to plug in that. So 0 to 2 square root of 18 minus t square, the whole square. Don't forget this. Plus y dash of t is minus t plus square root of t power 1.2 plus 20, the whole square. The square root will extend till here and then dt. Of course, it's very complicated integral, so we will use calculator. So, okay, so this one I'm going to do in decimals. Let me show you how it works. Okay, I have x of t, right? So, which is f of x. I'm taking as x. Okay, you can't use the parameter t here. So, x dash of t I'm taking it this way. F of x is 8t minus t square, but here I'm taking 8x minus x square. Then y of t I'm treating as g of x. So, you define the functions first because I'm going to use these two, right? So, which is minus t, but here minus x plus square root of um, t power 1.2. But here, for our Desmos, we are using x power 1.2. Just the variable I'm switching for the convenience. 20. Okay, what actually I need to do? Integral. Integral, it's looking for limit 0 to 2 and then a square root x dash of t the whole square. So this is my x dash of t. So I define it as f of x. So f of x, okay, we need a whole square. So let me use the bracket. F of x the whole square plus y dash of t, this green one. G of x is my y dash of t. So I will use brackets properly. G of x the whole square. And then don't forget to give dx outside the integral. Okay. So I got 15.90. Very simple. We can directly evaluate this integral from this. So with this reference, I will explain you in the board too. Let's go for the y. So how I calculated this means. So this is my x dash of t. I defined it as in Desmos. I just for my convenience, I named it f of x. This is my y dash of t. This integral. So you don't even want to do this, but they ask you to show and set up for a calculation. That's why we are doing this. And then directly you can apply this. Instead x dash of t f of x, bracket usage is important. Dx should be outside the square root. Okay, place it everything. There will be no error. You will directly get the perfect answer. 15.901. So which is approximately 15.9. If you're looking for three significant figures or three decimal places will be best. 3092. Rounding up to three decimal places. And total distance, if they give any units, you can use that. I think, yeah, they are telling in centimeters. So let's go with centimeter. That's the perfect completion of your answer, right? Now, moving to part C. Find the y coordinate of the position of the particle at the time t equal to 0. Show the setup for a calculation. Okay, what I need to find? Y coordinate at t equal to 0 means y of 0. Okay, this is what we need to find. Okay, what I have? I have y dash of t, which is negative t. This is given in the question, and we used it multiple times too, right? This is, I have, okay, so let's apply fundamental theorem. Okay, where you get y of 0? The antiderivative of the known thing. Antiderivative means you go for FTA. So integral 0 to 2 y dash of t dt as per FTA, its antiderivative of y dash of t, it's y of t. And 0 to 2, which is y of 2 minus y of 0. So I got this clue. 0 to 2 y dash of t dt is y of 2 minus y of 0. I am looking for y of 0 and I got this here. So let me make y of 0 as a subject. I am shifting this here. I am shifting this integral here. So y of 0 equals y of 2 minus integral 0 to 2 y dash of t dt. Okay. Yes. I will apply a property. You can use this or you can skip this step. Y of 2. So you can put a plus and 2 to 0 y dash of t dt. This way also you can do. This is also fine. This is also fine. I just converting this to a positive thing. Okay. So if you have to introduce a minus, so shift the limits. So this is my y of 0. Okay. So now I think this we can use Desmos. But what about y of 2? Let's look for our description anywhere. So yes. It's there. At time t equal to 2, the particle is 3 comma 6. So what this means? This means x of 2 is 3, y of 2 is 6. So y of 2 is 6. I need this. So I'm going to plug in y of 2 equal to 6 here. Okay. So I got y of 0 equal to 6 plus integral 2 to 0 y dash of t dt. Right? And what is your y dash of t? 6 plus integral 2 to 0 square root of negative t plus t power 1.2. Wait, it's actually negative t outside plus root t power 1.2 plus 20 and then a dt. So use the bracket. Now, yes, I have to go with Desmos here. Let's go. Okay, I'm not looking for this. So let me close it. This also not need here. So this is my y dash of t. I hope you remember. Now this integral part alone we need, or you can do with 6 plus integral 2 to 0 and then this g of x dx. Okay, don't confuse with t, it will show error. G of x dx. So I got negative 1.173. Okay, so let me take this here and I will explain you with the whiteboard too what I did. So to calculate this part, I have used Desmos. So I need to integrate basically this y dash of t. G of x is nothing but my y dash of t. Right? So that is what I did. And then 6 plus this integral I did. So 6 plus integral 2 to 0, all this will simplify to. So this is the second part. So negative 1.1736, something is going on. So approximately negative 1.174. Okay, this is about y coordinate. So you can finalize your answer by a good completion here. Y coordinate of the particle or y coordinate at time t equal to 0 is approximately negative 1.174. This is the conclusion here for part C. I hope it is understandable. Now we are moving to part D. Okay, yeah, let's solve this. So for time 2 to 8, the particle remains in the first quadrant. Find all times t in the interval when the particle is moving towards the x-axis. Give reason for the answer. So it is on first quadrant. And for 2 to 8, when it is moving towards x-axis. So your graph will be moving towards x-axis. Means y dash, okay, y of t should be in decreasing manner. Like this, it should be like this. So if you need this shape in y of t, y dash of t should be less than 0. This is the clue. So y dash of t less than 0, you solve for it. That only in this time interval, you will get this time stamp. Okay, find all the times. Okay, let's go. So what is y dash of t? Yes, it's given. Negative t plus square root t power 1.2 plus 20. So what I'm going to do is, I need where it's less than 0. So graph it and check where it below x-axis. You are looking for sign of this, right? So below x-axis, I need to look the time range. And also from 2 to 8 only, we are check. So here we are moving to Desmos. Okay, this is already graphed. This is the graph, which means y dash of t in our context, okay? Y dash of t, you need less than 0. So this is graph and it's been below y-axis, like below x-axis, after this particular value until 8. So yes, this is the answer. So we got the answer. That's very simple. So the times, we can interpret the result here. Whiteboard. So I got this. This is my y dash of t. So y dash of t is less than 0 for time approximately 5.22. So don't include it to 8. It is less than, like y dash of t is less than 0. Correct? So yeah, so that's the thing we have. And you can write this interval and interpret the result like this. The particle is moving towards x-axis. Towards x-axis. When? Like they are asking find all the times. So in this time range, t belongs to open 5.22. This is an approximate one. Or we can make 222, right? Comma 8. So this completes the solution for D part. I hope you got this. Now, also we complete the entire problem here. So thank you so much for watching. I hope this question might be helpful to you. Yes, it is a must-know concept for your BC calculus journey. So if this breakdown helped you, don't forget to like, subscribe, and check out the rest of the playlist for clear solution to every 2024 VCFRQ. Yes, if you got a different method or you're stuck on something, drop a comment. We are here to learn together. See you in the next one, only on Let's Unbound. Thank you so much for learning with us.